Okay, so this is the last word problem for exponential. So we did half-life, doubling, tripling. We did increasing and decreasing, or appreciation, depreciation. And then we're doing compounding periods. I like personally, if you look at it, this is the exact same formula as appreciation. F equals I times 1 plus interest rate over N. The only catch is that you'll know to use this particular formula is it'll say compounding. So what you have to remember to do is actually divide by compounding periods here and multiply by compounding periods here. So even if they give you the formula A equals P plus 1 to the n, you have to remember divide by compounding periods and times by compounding periods every single time. So even if they were that nice to give you the formula, they won't give you the CP part. You know to use this formula because it has the word compound in it. So we're going to do this question here. Okay? If it says, so this would be your final, this is your initial, I would personally, the only reason why I showed you this formula is because if they give you the formula, they label them as A's and P's. But if I use the formula, I just do F and I so that it's the same formula for basically all of them. A little bit of a twist. I is your interest rate in decimal form. And here it says, remember, you need to divide by those compounding periods. And then N is the number of years. It's always years. And then here it says, and remember to multiply by the compounding periods. If it says it compounds, if it says annually, that's once a year. Now, what the heck does compounding even mean? If you have a loan that compounds, let's say not a loan, let's say an investment, because it sounds better when you're making money. So if you have an investment and you put in, say, $1,000, and say it compounds monthly, at the end of the month, you're going to make interest on that $1,000, right? And if it compounds monthly, what it does is it takes the interest you made off that $1,000, it puts it in, and now the next month you're making interest off your $1,000 plus the interest you earned on that last month. Then at the end of that next month, it takes the interest you earned off the interest and the amount of money you put in, and it rolls into that. So then the next month, you're making interest off the money you put in plus the last 2 months' interest, right? So you're making interest off of interest is what you're doing with compounding. Great for loans. I mean, great for interest, bad for loans, because what if you compound, the more you compound with a loan, the more interest you're going to have to pay, right? So you invest $500. So that's going to be your initial. So 500. In an account paying 6%. So that's my interest rate. So I'm going to go 1 plus 0.06. But I'm going to remember to put a line underneath it because I need to divide by the number of compounding periods. Now it says compounded semi-annually. Up here, annually is 1. Semi-annually is 2. So 2 times a year. Monthly is 12. And then the other one that they use often is quarterly. How many quarters are there in a year? 4. Quarters are just seasons. Spring, summer, fall, winter. So there's 4. So in this case, it says compounded semi-annually. So I'm going to put a 2 here. And then I'm going to go 2n up here, because I don't know what n is. And I'm going to leave this be an A, or I'm going to leave it be an F in my case, because I like it being final. I like it using the letter F, but you can use an A if you want. So we're just writing an equation. At this point, we actually can't solve anything, right? But I'm going to reduce this part first. So 0.06 divided by 2 is 0.03, plus 1 is 1.03. So F equals 500 times 1.03 to the 2n. Can I make that 500 join that 1.03? Can I just times them out and life is good? No. What do I have to do with that 500 always? either put it in after I expand the exponent in, or I divide it over to the final, right, if I'm looking for n. So here it says, estimate the value of the investment after 5 years. Is that f or n? That's 5. N, because this is the number of years. So we know n. So we have f equals 500 times 1.03 to the 2 times 5. Do you know when people y1, y2 this? Don't. F equals this. Just do this in your calculator, the main screen. Go 1.03 to the 10, enter, times 500. I do them separate because if not, you have to have your brackets correct, or else what your calculator is going to do is it's going to multiply these and raise that to the 10, which is not the answer. So I'm going to go 1.03 to the 10, and then times that by 500. So does that make sense? In 5 years, if I invested at 6%, I make about $171 off of 500. That makes sense. Some people like have 500 as the initial value, and then they have them making $20,000 in like that doesn't even make sense. Like that's like way more than double, right? So watch your initial, see if they make sense. If it doesn't make sense, go back, try again. Okay. And then use a graph to estimate. I don't really want you to use a graph. I want you to actually figure it out. So we want to know when this investment will double. So the investment doubles. That doesn't mean go do the doubling formula with doubling, half-life, tripling. It just wants to know when the investment doubled. How much was the investment at first? 500. How much is it when it doubles? 1,000. So they just want to know when the final amount is 1,000. So I go 1,000 equals 500 times 1.03 to the 2n. Don't put 5 back in. 5 is when you found for 5 years. We're trying to find n. So the first thing I told you guys to do always is divide that I over. So you don't have to make your window so crazy. So now I have 2 equals 1.03 to the 2n. And remember, if your calculator doesn't raise the exponent up, this 2n needs to be in brackets. If you don't put that 2n in brackets, you're going to get it wrong every single time because it's going to go 1.303 to the 2, and then it's going to multiply it by n, which is not what you're actually wanting it to do. Okay? So always put your exponent in brackets if it doesn't raise it up. So y1 is 2. y2 is 1.03 to the exponent 2x. Now let's think about it. It took 5 years to make 171, but it's growing exponentially, right? Because it's making interest off your interest, right? It's not just going to be a steady straight line. So second trace 5, enter, enter, enter. If it errors you, what do you need to change? Your x max. What happens is that if you're trying to find, like, say, 30 years, but your x max is only at 10, it can't calculate it, right? Because you can't see it. So I have my window set at 10, and it said error sign change. So I'm going to make my y or my x max be like 30. I can see the whole graph, so I don't need to like. So what people do when they can't get it is they go, all right, I'm going to make my x minimum be negative 1,000, and my x max be 10,000, and my y minimum be negative 500,000, and my y max be like 1 million. Like you guys just go from like an extreme of 10, 10, 10, 10 to like 500,000. Like, don't go wild. You can see the graph. You don't need to change a whole bunch of things. Just make your x max bigger. Because if you make your window so big, it's chaotic. That is what I've seen everyone do. Like they have 10, 10 window, and then it's like 500,000, 500,000, 500,000, 500,000. With some negatives, because that wouldn't make sense if you just did 500. My y max is 10. And I know I don't need a bigger y max because this y is 2. If this y was like, say 1,000, then I need a y max bigger than 1,000, right? Because it's drawing a horizontal line at that value. So here I have a horizontal line at y equals 2. If this was 1,000, I need a horizontal line at y equals 1,000. So I need my y max to be at least that big. So that's why I told you to always divide the I over, because if not, you would have needed your y max to be greater than 1,000 in order to see this, right? Okay, so I got 11.72. What if it was 11.12? What would I still round to? 12 years. You always round up when it's time, because if not, say it was 11.12 and you rounded down to 11 and you needed to have double the amount of money, you're not going to have it. Okay? You guys try 12 and then we're moving on. Okay, so 7,000 is invested, so I'm going to put that in for the P, which is just the I, and this is the F, right? In a 6-year GIC, compounded quarterly, so CP is 4, at a rate of 5%, so 0.05. If you don't know how to get percents down, divide by 100, right? To decimal. Determine the number, the value of the investment at the end of the year, so we want the final value. So final equals initial times 1.01 plus 0.05 divided by 4. And then this is going to be 6 times 4. So what I like doing first is I like going 0.05 divided by 4, adding 1, raising that whole thing to 24, and then timesing by 7,000. So 0.05 divided by 4 plus 1. If you want to not do it in one step, go ahead and do this. 1.0125. Can I ever round this decimal? Say this doesn't work out to a nice decimal. It's really long decimal. So if I just round it, that's fine, right? No, that's wrong. You cannot round until your very last step, please. Please, please, please. So 2 to the 24 times 7,000. And you get 9,431.46. I'll give you the homework for those 2 questions later. Is it 4 what? 457? Like 0.457? So I did 4.6. You money round up. Trust me, you do. On these ones where they're stickly, a lot of the time. So logs and exponents, you use them together, and that's why we put them together as a unit, even though they're 2 separate units in the textbook, 7 and 8, because and log is a inverse of an exponential, and an exponential is an inverse of a log. So until now, if we had 2 separate bases that we couldn't make be common base, we y1, y2'd, right? That was the only way we could solve for that exponent. Well, actually, what you can do is you can convert it to a log and solve it. And concurrently, if you have a log and you have a value of x beside it or in the base of the log, and you want to solve for those, you can change it to an exponential and solve, which will make sense in a little bit. So for the function y equals 2x, the inverse is x equals 2y, right? We just switched the x's and y's, correct? But how do I type x equals 2y into my calculator? I can't. I only have a y equals button, correct? So in order to solve this, we have to get it into y equals. So if you look on your lovely formula sheet here, you are not as lucky as 30-2. These are the formulas you are given for logs and exponents. So laws of logs here, which we're going to learn soon. They look a lot worse than they are. They're not really this ugly looking. This is the growth decay function, so they give it to you, that one. But they don't give you the one where it's like 1 plus or 1 minus, right? So you have to know that one. But this one they give you. And then this is just back to just normal transformations. So those are the only ones you give you. They're given to you. For 30-2, they give the conversion between exponential to log and log to exponential. You don't have that, so you're going to need to know it. So it's actually not very hard. So I call this the base because it's the base. This is also the base of a log. It's like a little lowered number. So if I have the base of my exponent and I change it to a log, it's the base of my log. They're the only things that stay the same. So the base of my exponent and that becomes the base of my log. Now what I say is whoever's friends in exponential is not friends in logs, and whoever's friends in logs is not friends in exponential. It's like they fight in between. I don't know why. So the x is with the b here. Is the x with the b here? No. So I just write my bases first, and then this one goes with the base because it's not with it here, and it gets set equal to my exponent always. You'll practice it enough, it'll be part of your being anyways. So if I look at this one, it's y equals 2x is the original, 2 to the x. But the inverse is x equals 2 to the y. The only way I can get it into y equals is turning it into a log. Why the heck would we want to be able to change this to a log? Because normally we're solving for this exponent, and the only way we know how to solve for that exponent so far is making it common base, right? Or y1, y2. We can't actually do it any algebraic way, correct? But now we'll be able to, because we can change it to a log. So what do? What is my exponent? It's what it's equal to, because it's with it now, equals log. The base of my exponent becomes the base of my log, so it's a little 2 down here. And then this x joins it because it's not with it up here. So this is actually the inverse of this. Type y equals 2x into your calculator. I can't bring my calculator up. It's like really angry on me and it won't even let me do it, so I have to download it again. So put y equals 2 to the power of x in y1 and put this into y2. How do we put that into y2? Well, we're going to learn later, but I'm going to teach you now. Okay? So there's 2 ways. If you have the fancy calculator that's exponent pops up, you have a button. So if you have the fancy calculator where the exponent pops up, follow along. In y2, you're going to go math, and you're going to arrow up until you get to the log base one. It like literally looks like a log and it has 2 spaces. Okay? So math, and you arrow up till you get to the one that has logs, and then you'll put a 2 down here and an x in here, and you have it. If you have the new calculator, you'll know what I'm talking about. If you press math and you arrow up and there's no log base thingy, sorry, you don't have it. Okay. So the way, no. No. Clear. Math, arrow up. Here's yours, log base. It says log base, and then put it in there. No, you can't press that. If you don't have the log base button, you're going to do this. It's not substantially harder, it's just a little bit more work. So the way you can type this into your calculator is I always just draw a line through it like this and put a log on the bottom. So how are you going to type it in? You're going to type it in as y2 equals log x divided by log 2. And this lovely ditty up here gives it to you. So if you look here, it has extra a's in it, but it doesn't matter. Log BC is log C divided by log B. Ignore these a's for now. I'll explain why they're there later. Okay? I just draw a line through and just put a log on the bottom and put it in. So type those into your calculator. Now go to y3 and type in y equals x. Just x. Into your y3, type in y equals x. And press graph. y1 is 2x. Log is right here. 2 to the exponent x is in y1. This is in your y2. And in your y3, you should have just y equals x. Press graph. Is your graph reflected on that y equals x line? The y equals x line is the identity line. It's the 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If these are inverses of each other, they should be reflected. That little y equals x line should be a mirror. If you have 2 graphs that do not look like they're reflected on it, and one of them is going through like y equals x, you typed it in wrong. Okay? This is 2 to the exponent x.
Oh, thanks.
No, you're good. You're right. Okay? So let's go through this part. Oh, I've been letting that run. That's nice. Okay. So generalize. We need to be able to switch between exponentials and logs and to use this in order to solve equations, okay? So exponential to log form. Remember that the base in the exponential form is still the base in the log. Always equals to the exponent. So we have AB equals C. That's going to be B because it always equals the exponent. And why would it equal the exponent? Well, we want it to equal the exponent because that's the value we don't know. If we can get value we don't know equals something, well, we just type that something in our calculator and we have an answer, correct? So that's why we always want it to equal the exponent. So when we change it to a log, it's awesome because it just equals the exponent, and then the extra information we punch in our calculator to get an answer. So we're going to get B equals log base A, because this is the base of the exponent. It stays the base of the log. So it's a little a down here, and then C. Log to exponential, I find easier because I always write the log on the left and then do a 7. I'll explain to you in a second. So here the log is on the left, and then I do a 7. 3 to the exponent B equals A. 3 to the exponent B, see it's going upwards. 3 to the exponent B over the equal sign equals A. 3 to the exponent B equals A. If you have log on the left, you can always do the 7 rule. But you can only have one log. If you have 2 logs, like a log on one side and a log on the other, you can't do this. So this one I'm going to rewrite. I'm going to go log C E equals, that looks like an E anyways. That's a C. Log C to the E equals D. Then I'm going to do 7 rule because I have to put my log on my left. So C to the exponent D equals E. C to the exponent D equals E. And you'll be able to do this backwards and forwards, trust me, because you'll use it a whole bunch of times. So we want to change from exponential to log form. So we have exponential, we need to change to log. It always equals the exponent. So 3 equals log base 6, because the base of the exponent is the base of the log, and then 216. You try these ones. Okay, it equals the exponent, so 4 equals log base of the exponent goes base of my log 3, and then 81 goes to 7. This one equals the exponent, so negative 4 equals log base 2, 1 over 16. Then here equals the exponent, negative 1 equals log base, this is the base of the exponent, so it's going to be the base of my log, 2x plus 4, a. Changing from log form to exponential form. If you put the log on the left, you're golden. So it's going to be 5 to the 3 equals 125. 5 to the 3 equals 125. So 5 to the 3 equals 125. I'll let you do the other ones in a second. But one thing you need to pay attention to, when there isn't a base on the log, there actually is a base there. So, you know when you take a square root, right? When you take the square root of something, you know it's a square root even though it doesn't have a 2 there, right? But if it was a cube root, I'd have to put a 3 on the index. And if it was the fourth root, I'd have to put a 4. And if it was the fifth root, I'd have to put a 5, right? Same thing with logs. The only one you don't have to write a base for is base 10. So if ever I see a basic log like this, I instantly write the base 10 below so that when I go to change this to exponential, I just go 10 to the 3 equals 1,000. But if I don't have that base, then people sit for a while. So if it's missing a base, I just put a base 10. So you try the other two. So then here I'm going to go 4 to the negative 2 equals 1/16. And then k to the x equals t. Okay. So, how do I put this in to my calculator if I don't have the base button? I'm going to go, if I have this, log base 2, 8, and I don't have the base button in my calculator. Remember, even if you don't have the base button, make sure you can do this anyways, because you're going to have to do it to solve some logs anyways. So I draw my line through it, and I'd put it in like this. So go log 8 divided by log 2, and you tell me what the answer is. It's 3. What's this one going to be? Log what divided by what? It's going to be log 4 divided by log 2. What do you get? 2. What's log 2 divided by log 2? 1. What's log 1 divided by log 2? 0. What's log 1/2 divided by log 2? Log 1/2 divided by log 2. -1. And what's log 1/4 divided by log 2? -2. Now, you don't actually have to punch those in your calculator. What you can do is you can do this with logs. So you can always punch them into your calculator if you want, if you're stuck. But what you can do is you can go like this. If it's in just a basic log like this, you could say 2 to what exponent is 8? 3. 2 to what exponent is 4? 2. 2 to what exponent is 1? 2 to what exponent is 2? Sorry, 1. 2 to what exponent is 1? 0. 2 to what exponent is a half? Well, -1. 2 to what exponent is a quarter? -2. So, based on that, what's log this? Well, I could go into my calculator, log 9 divided by log 3. Or I can say 3 to the what is 9? 3 what is 9? 3 squared, right? So it's just equals 2. 4 what? 4 to the power of what is 16? 2. 5 to the power of what is 125? 5 cubed is 125. 3 to the power of what is 27? 3 cubed is 27. So my answer would be 3. B to the what exponent is 1? 0. What's log b divided by log b? 1. Because you guys told me that log 1 divided by 1, right, is 1. So this would just be, oops, this divided by this. So it's 1. So if you actually have your notes, we're going to finish the rest of this tomorrow. But what I want you to do is flip to, oops, this part here, assignment 380, and I'll tell you what you have to do. Plus you have a couple questions on